So now this video discusses about the friction forces and also the motion of the objects. But make sure before you go for this lesson, you need to understand about the concept of the Newton's third law of motion. You need to understand about the Newton's second law of motion. Should be second law of motion. That is the second law of motion. You also need to understand about the Newton's third law of motion. So also be in need of the Newton's third law of motion. And you should also have to be well conversant with the force analysis. You should have to understand about the force analysis. And basically we're trying to look at the for actually vector resolution. You should be well oriented with the vector resolution concept. So vector resolution, you should have to understand much about the vector resolution and before you go for this lesson. And otherwise we just have to look at how we can have to apply these things in the video. So we'd like to look at what we call as the friction forces and also what we call as the motion of the object. But make sure before you watch the video, before you proceed the video, you have subscribed to the channel and thus being part of the support system, so that we should have to reach as far as possible. So make sure that you have done that. Now we have two types of friction forces. We have what we call as the kinetic friction force. We have what we call as the kinetic friction force. So what is the kinetic friction force? Kinetic friction force, it is the friction force associated whenever there is a movement of the object. That is what we call as the kinetic friction force, and it is given as Fk, which is equal to mu k times the normal force, where mu k is said to be the coefficient of kinetic friction force, and where n is the normal force. And we also have what we call as the static friction force. So what is the static friction force? Now static friction force, it is the friction force associated with the objects that are not moving. So as the name itself suggests, static means being at rest, and that is given as Fs, which is equal to mu actually s times the normal force. So you should have to understand all these types of friction forces. Whenever an object is moving, the friction force in associate, we call it as the kinetic friction force. And whenever the object is at rest, the friction force associated with that system is said to be the static friction force. So keep that in mind. And before we actually further go in details about the friction force as well as the movement of objects, you should have to understand about the Newton's second law of motion, a part of it. We understand that, let's say if this is an object, and let's say it is the object of mass m, and say the force F has been applied on the object. In other words, the object is subjected to the force F. Now for that case, since there is a force being applied, now wherever there is a force, there is an acceleration of that particular object. In that case, it means the object will accelerate towards this direction. According to the Newton's second law of motion, the force responsible for the acceleration is given as F is equal to mass times acceleration. So this is what we call as the Newton's second law of motion, which states that the force responsible, the force applied on the object is directly proportional to the mass of the object and its acceleration, and basically it is given in newtons. So now What happens if the object is moving at a constant speed? Now, if the object is moving at a constant speed, we have to understand that the object moving at a constant speed, it means the acceleration is zero. And for instance, you have to recall that, let's say we have the acceleration being given as the final velocity minus initial divided by t. If the acceleration is zero, it means we have zero is equal to the final velocity minus initial divided by t. If we cross multiply, we have it as 0 is equal to v minus u. So in this case, final velocity is the same as the initial velocity, and this is when the object is moving at a constant speed. So whenever the object is moving at a constant speed, final velocity is the same as the initial velocity. So that is only happens whenever the object is moving at a constant speed. So constant speed, zero acceleration. Now, if the object is moving at a constant speed, acceleration is zero. Hence, the Newton's second law of motion, the forces acting on the object, that up to. So, in other words, the object moving at a constant speed, it means the forces acting are balanced. That is, the net force acting on the object is given as zero. So, keep that in mind. So, constant speed is our acceleration. That would be the way out. You should have to get. So let us see how we can have to apply the friction forces and in relation to the objects that are in motion. Let's say we have, this is the typical object. Let's say this is the object of, let's say, mass is 6 kgs. Let's say that is the case, and we have the force being applied. Let's say that is the force, and which is given, let's say, 60 newtons. Let's say that is the case, and now let's say we have the friction force that opposes the motion, and since the object is in motion, the friction force will be the kinetic friction force. Now in this case, what is the acceleration of the object if the coefficient of the static friction is given as, let's say, 0.2? So what do you think will be the acceleration of the object if the coefficient of the static kinetic friction force is given as 0.2? So looking at the case that we have here, we should have to analyze the all forces acting on the system, and basically we should have to present the free body diagram. We have the force being applied, that is given as the force being equal to the 60 newtons. Let's say that is the case, and we have the weight of the object which is pointing downwards, that is given as the weight which is the same as the mg, and we have the kinetic friction force that is opposing the motion, which is given as the Fk. And according to the Newton's third law of motion, the weight in which the object is exerting on the ground, the ground exerts back the same force that will act upwards, and that is said to be the normal force in that way. Now, since the motion is taking place along x-axis, then we'll say summation of the forces along x are the ones responsible for the acceleration along x-axis. And what are those forces? We have the force F, and which is acting towards the direction of the motion, and minus the actually kinetic friction force, which is Fk, which is equal to mass times the acceleration. So keep that in mind. And from there, you should also have to understand that, we have the force applied, which is 60 newtons, and minus Fk, we do not have the Fk, and what is the mass? We have it as 6 kgs in terms of the acceleration that we are told to have. Then we need to have what is kinetic friction. Actually should be the kinetic friction force, whose formula is given as the mu k times the normal force. So we have the mu k, what you need to have is the normal force. How do you think we should have the value of the normal force? Well, we should have to go actually to the forces acting along y-axis. Since there's no motion along y-axis, the summation of the actually forces in x and y is given as L. And if that is the case, we have the normal force which is acting up, and we have the weight of the object which is acting down, and that's equal to L. And for this case, the normal force will be given as the weight of the object, which is the mg. So now you can be able to have the normal force. That will put it here, and you'll have the Fk. Then you put it here, you solve for the acceleration. That's how you should have to understand it. And upon having the acceleration, we can be able to, let's say, have the distance traveled, final velocity, and sort of using the equations of kinematics. So that's how you should have to understand about that case of the motion. And now let's say we have the same system. Let's say this is the object, and let's say we have the force that is acting at an angle. Let's say the force is given as should be 90 newtons. Let's say that is the case, and the force is acting at an angle, let's say should be 20 degrees with respect to the horizon. And let's say we have the another force, let's say, which is acting like this, and that should be equated as F2, that is should be given as the 20 newtons. And say it is acting at an angle, let's say given as 30 with respect to the horizon. That should be angle 30 rather, should be that. And let's say the motion is taking place towards this direction, like that. So what is let's say the object is of mass 20 kgs. So how do you think will be the acceleration of the object? If the coefficient of the friction, actually if the coefficient of the, if the coefficient of the kinetic friction is given, let's say 0.3. So how do you think we should have it? Principle remains the same. We should have to resolve the forces acting into the components, and we should have to look at the forces that are acting in the direction of the motion, and thus you should have to think it as being something about, and for that case we should have to resolve, let's say we need to resolve F2 into components, where this is y component and this is the x component, that is going like that. Let's say that is the case, and I should also have this as well. So make sure you have the good understanding on the vector resolution, and that's the basis of this. And let's say this is the case, this is the y component, and this should be x component, and this is the y component. And apart from these forces, there is also what we call as the weight of the object, which is pointing downwards. And according to the Newton's third law of motion, there is also what we call as the normal force, which is acting up. So how do you think we should have that? So let's think of having the free body diagram and showing all these forces. And mind you, free body diagram shows the object, it will actually present the object as a point particle. We have the force, that is let me just have this one as a force F1. Let's say that is the force F1, which is given as the 90 newtons, and of which we have the we have the weight of the object, which is pointing downwards. And mind you, this is the given as the mg. And we have also seen that we'll have the force that will act on the object at an angle. We have that, and where this is the force F1, which is given as 20 newtons, and the force in which the actually that is F2, by the way, that is F2, and the F1 it is at an angle of 20 degrees with respect to the horizon. That is, and of which this is upon resolving, we can have, this is the x component, that is F1x, and this is the y component, that is F1y, and we should also do the same with the other force, that is and we should have that understand. So this is F2x, and this is F2y, that is the y component. So keep that in mind, and mind you, the motion is along x-axis towards this direction. And apart from these forces, we also have what we call as the kinetic friction force, that is stromal opposing the motion, but it is pointing towards this direction. And since we have been given the mu k here, so for this case it means we'll also have the another force which will oppose the motion, that we can have it as the kinetic friction force, that is Fk, like that. So according to the Newton's second law of motion, what are the forces that are acting in the direction of motion? And by the way, the motion is taking place along x-axis. Therefore, the summation of the forces along x are the ones responsible for the acceleration. And what are those forces? We have one Fx, which is pointing towards the direction of motion. It will be positive. And plus, we have F2x also pointing towards the same direction of the motion. And the minus Fk, since it is opposing the motion, is equal to mass times acceleration, like that. And from there we should have to resolve the forces, which should have what is F1x, F2x, and keep in mind that Fk corresponds to have it as the mu k times the normal force. So how should you have the normal force? So we need to look at the forces acting along y-axis. Now since there is no motion along y-axis, it means the summation of the forces along y, they add up to 0. And because there is no motion along y-axis, therefore the summation of the forces along y, they add up to 0. That's how you should have it. So in this case it means the summation of the forces along y, they add up to 0. And what are the forces along y? We have the y component of the force F1, which is pointing up. We have it as the positive 1y. And we have the y component of the force 2 that is pointing down, or have negative F2y. And we also have the weight of the object, which is given as the negative. And by the way, there is also what we call as the normal force, which is pointing up. That is, now since it is pointing upwards, that is plus normal force, which is equal to 0. Then since you have F1y, F2y, and the weight, you can be able to have the normal force. That will substitute here to have the Fk, then you put it here to have the acceleration. So that's how you start to understand that. So whenever an object is moving, the friction force is said to be the kinetic friction force. But whenever it is at rest, the friction force is said to be the kinetic, actually static friction force. And let's say we have the system on a inclined plane, and see how we can have to appreciate that. Let's say we have the inclined plane at an angle theta with respect to the horizon, and let's say this is the object on an inclined plane, and let's say the plane is rough. The surface of the plane is rough. Let's say that is the case, but now the object tends to accelerate down. How should you have to find the acceleration if that is the case? Now let's analyze the forces acting on the object. Let's say we have the weight of the object. That will go like this. This is the weight of the object that is pointing down like that. And in all cases we have the normal force, that is given as A. And we have another force that goes like this, should be that. And according to the geometry, the inclined angle is the same as this angle, which is given as that. And if we think of having this one as a Cartesian plane, what you can have to see is that we have that one as a y-axis, and this is x-axis. So this is the x-axis and this is the y-axis. You just have to look up to that one. Now it means the weight of the object, it is at an angle theta with respect to the y-axis. Now since the surface is rough surface, as the object is moving downwards, and by the way, what are the forces? We can be able to resolve the weight into components. We have the y component, which is weight cos theta. It should be that. And we have another component, which is given as the weight sin theta. That is the y, actually x component of the weight of the object. And now the object is said to be sliding down. That is acceleration along x-axis. But now since the surface is a rough surface, then there is what we call as the kinetic friction force, that is to oppose the motion. So now since the motion is in along x-axis, according to the Newton's second law of motion, summation of forces along x are the ones responsible for the acceleration. And what are those forces? We have the weight sin theta, that is a positive since it is acting in the direction of the motion, minus Fk, which is equal to mass times acceleration. And for this case, we need to have what is Fk. You know, Fk is given as, you know, mu k times the normal force. And how should you have the normal force? We'll now look at the forces acting along y. Now, since along y-axis there's no motion, summation of the forces along y add up to 0. And what are those? We have the normal force minus, you know, weight cos theta, and that is equal to 0. And from here you can be able to have the normal force, which is given as the weight times cos theta. So that's how you should have it. Upon having the normal force, you put it here, you have the Fk. That's how you should have to understand it up. So keep that in mind. And let's say this is the question. And from there you will be able to have the acceleration of your interest, that is. Now let's consider this question. You know, a question says that a 200 Newton container, you know, a 200 Newton container, we have the weight of the container, which is given as, you know, 200 newtons, is to be pushed across the rough surface. That is, it is to be pushed across the rough surface. And where we have the mu s being given as 0.5, of course 0, like that. And we have the mu k, that is given as 0.400. And most of the times, and generally, the always, mu s is greater than the mu k. That is always that is the case. Now the first question says that what is the force necessary to start the container moving? We are looking for the force necessary to start the container moving. And basically that force, by the way, at this point it means the container is not moving, but it is the force necessary to start the container moving. So it means we are looking for the static friction force, which is given as that of mu s times the normal force. But looking at the case, let's say this is the container of our interest, and we have the weight of the container, which is given as W, and we have the normal force, which is acting downwards. It should be upwards rather, like that. So we are looking for the coefficient. It should be static friction force. That is the force responsible, you know, that is the force responsible to start the container moving, like that one. So in this case, you can see that the normal force will be the same as the weight of the object. Therefore, we should have to understand that the normal force will be the same as that of, now have F(s) is equal to mu(s), actually mu(s) times the weight of the object, since the normal force is the same as the weight, according to the diagram that we had. And what is the question B? The other question says that we should have the force that is to keep we should have the force that is that will keep the container moving at a constant speed. Now it means the container now is moving. Let's say this is the container like that. So we're looking for the force like that. That is making the container to move at a constant speed. And of course we have the weight of the container like that, and we'll have the normal force that will go like that. Now since it is moving, it means we'll have the should be kinetic friction force that will go like that one. So since it is moving at a constant speed, it means the acceleration will be given as 0. Hence the summation of the forces along x that up to 0. Object is moving at a constant speed, and this is in line with the Newton's first law of motion. It means the object is under balanced forces. Hence it is what we call it as translational equilibrium system. That is the system which is moving but under the balanced forces. Now in that case it means we have the force applied minus Fk, which is equal to 0. We're looking for the force applied. A force applied is equal mu k times the normal force, which is equal to 0. We have the normal force being the same as the weight of the object, and we have the mu k, which is given as this. We can be able to have the force applied in that way. And let's say we have this kind of equation: a 0.00 kg toy, that is the mass, given as 2, should be a 2.00 kg, that is, let me just have to use that as 2 kg. Accelerate from rest, it means the initial velocity is 0, and the final velocity is given as 3 meters per second, and we have the time, which is given as the 8 seconds. It is on the rough surface where mu k is given as 0.3. Let's say that is the case, and the question says that we should have the value of the force applied. So a first thing, let's analyze the forces acting on the system. We have the force being applied, that's what we're looking for, and we have the weight of the object, that is given as the mg, that is the weight, by the way, and we have the normal force, which is acting upwards like that. And since it is moving, it means the force is said to be a kinetic friction force that is acting like that. So in this case, since the motion is along x-axis, it means the summation of the forces along x are the ones responsible for the acceleration. And what are those? We have the force applied minus Fk, which is equal to the mass times acceleration. And we need to have Fk. What is Fk? Fk is given as mu k times the normal force. And how should you have the normal force? We have to go to the forces along y-axis. That is, the normal force is equal to the weight of the object. So we are done with Fk. But what is also needed is the value of acceleration. So looking at the parameters that we have, acceleration will be obtained using the equation of the kinematics. Since we have the initial velocity, final velocity, as well as the time, acceleration will be given as final velocity minus initial divided by time. So upon having acceleration, we put it here, and then solve for the force applied. And now let's consider this kind of a actual equation. A 23 kg box, we have the mass of the box, which is given. Let me just have to stand like here. We have the mass of the box, which is given as 23 kgs. Mind you, the masses have to be in kgs. And I moved it along the rough flow at a constant speed. So being at a constant speed, it means the acceleration is given as L in all cases. And we have mu k that is given as should be 0.3, like that. Now the first question says that what force F1 you must exert if you push it downward on a box as shown, that is in figure A. So what is the value of the force F1 must be exerted as the object is being pushed like that? So let's analyze the forces acting. We have the weight of the object going over like that, and we have the normal force which is acting up. And since the object is moving towards this direction, then there is what equates as the kinetic friction force that is opposing the motion, that is Fk. And of course we should also have to resolve F1 into components, where we have, this is the y component and this is the x component, which is going towards this direction, that is F1x, and you can have, this is the y component given as should be F2y, or have it as F2y, so like that. So that's how you just have to understand it. Now since the motion is along x-axis, it means the summation of the forces along x are the ones responsible for the motion. And by the way, since it is moving at constant speed, it means acceleration is zero. Hence the summation of the forces along x that up to 0. So have it as 0 since acceleration ax is 0. And what are the forces along x? We have, F1x, that is the x component of the force F1. By the way, we should also have F1 here, not F2. And minus Fk, which is acting against the motion, is equal to 0. And we understand that F1x will be given as F1 should be cos 30 minus Fk, which is equal to 0. By the way, Fk is said to be mu k times the normal force is equal to 0. And what is the normal force? We should have to go in the forces along y-axis. So since there's no motion along y-axis, then it means the summation of those forces along y add up to 0. And what we can have is the summation of the forces along y add up to 0. And what are the forces? We have the normal force which is acting upwards, and we also have the y component of the force F1 which is acting down. We have it as F1y, and the minus the weight of the object which is equal to 0. Then now we can be able to solve for the actually a normal force. That will be substituted here, and I'll be able to solve for the value of F1, which is that one. So keep that in mind. And question B also be done in the same way as we have done with question A. So try that one. And let's also see this kind of equation. A block slides along a wooden table with an initial speed of, we have the initial that is given as 5 centimeter per second. Of course it has to be in actually meter per second. You just have to convert. That is, we have the initial that is given as 50 centimeter per second, of which it has to be in meters per second. You just have to convert. and if the block comes to rest, it means the final velocity is 0. And the question says that find the kinetic friction. Should be find the coefficient of the kinetic friction between the block as well as the tape. We are looking for should be that of Fk, and since should be that, and in this case let's think of presenting should be the forces acting on the object. Let's say that is the case. This is the object like that, and we do not have been given anything to do with the force applied. It means we assume that there is no force being applied. Now the only force which is there, it is should be that of the friction force, that is Fk. And let's say this is the object like that, and we have the forces acting. We have the the weight of the object, and there should be that, and we also have the normal force that is acting upwards like that. And now, since the motion is taking place should be along x-axis, it means the summation of the forces along x are the ones responsible for the motion. That is, you just have to get. And what are the forces along x? We have only that of Fk, which is negative since it is acting against the direction of the motion, which is equal to the mass times acceleration. But we need to have the value of, Fk is given as the mu k times the normal force, of which, as this sign here, means the normal force will be the same as the weight of the object. But the weight of the object is given as the mass times acceleration due to the gravity. So which means now the Fk is given as mu k times mg, which would have to substitute it here. That is, now we have it as negative mu k mg is equal to mass times acceleration. This mass and this mass will cancel. What we need now is to have acceleration, and the acceleration will be obtained from the equation of kinematics. Since we have the initial velocity, we have the final velocity, then we have the displacement as well, which is 150 centimeter, but it has to be meters. You should have to convert. So we can be able to have the acceleration, put it here, and then solve for actually mu k. Rather, solve for mu k. So that's how you just have to understand about that one. And basically, acceleration will be negative. Hence, with this negative, actually the negative so-called. So that's how you just have to understand it. And now, let's say we have this question. The question says that what force must act horizontally? So we have the object. Let's say this is the object with the force that is to act horizontally given as F. We have the object of mass. We have the mass which is given as 20 kgs, like that. And object moving at a constant speed of, we have the constant speed. I'll call it as the u is equal to 4 meters per second. But I may have it as, being it is a constant, let me have it as v, that is the constant speed. Of course, at a constant speed, it means the initial velocity is the same as the final velocity. So whichever the notation, it will be okay. And on your rough table of the coefficient of the coefficient of the kinetic friction, that is we have the mu k is given as 0.30, should be 0.0 rather. So we need to have the force applied If that is the case, it means we have the kinetic friction force that is opposing the motion given as Fk. We have the weight, and also we have the normal force that is acting as that. Now in this case, now you should have to understand that in this case, the summation of the forces along x are the ones responsible for the motion. Now since it is moving at a constant speed, it means the acceleration is zero. And what are the forces? We have the force applied minus Fk, which is equal to 0. Now from this actual analysis, you can be able to have the force applied like that. And check the other question. The other question says that if the force is removed, when will the body comes to rest? It means on the second case, we should have to regard that the initial velocity is 4 meters per second, and the final velocity will be given as our since it will come to rest. When will the body comes to rest? We are looking for the time it takes. So like that, and just have it in that way. So it means if from here we should now have to, by the way, if the force is removed, which is this force, it means the only force that will be there, it is kinetic friction force. So if that is the case, then Newton's second law of motion says that the summation of the forces along x, which is negative Fk, will be equal to the mass times acceleration, of which acceleration will be negative. Then we are going to have the damped x with acceleration, using the equation given as acceleration is equal to v minus u over t. You'll be able to have time. And the other question says, where will it come to rest? We are looking for the actually displacement, and that you can have it there. So that's how you start to understand about the aspects of the friction force and related to the actually motion of the object. So don't forget to subscribe if you find it good, and also share your friends and loved ones. Thank you.